Here is the Bally Flash Gordon pinball machine, and we've done some more repairs to the pinball machine in the past couple weeks. I'd like to thank someone for giving me a tip on this from the original video I made of the pinball machine. He recommended that the bridge rectifier BR1 may be bad because the playfield feature lights weren't coming on. And sure enough, it was bad. And the wiring was burned on the printed circuit board. So what we did was to resolder new heavy gauge cables in place of the old BR1 and ran them to a new 35 amp 1000 volt bridge rectifier, which I mounted on the mounting bracket here. Used heatsink grease under it for heat transfer and mounted it there for good heat conductivity. So now I have the playfield features working. I've got a lot of the rubber bumpers replaced, and one thing right now, I'm looking for a stuck switch on it. Now come on and focus on it there. What I'm going to do is go into the Bally self-test mode and show how it detects the presence of stuck switches and also some of the other features during the self-test. So I'll first power up the pinball game down here. I'll go through its power on self-test routine. And now what I'm going to do is to press the self-test button, which is inside the coin box door here. So when I press it once, this flashes all the feature lamps so that you can see if any of them are burned out. Now when I press it again, it does a solenoid test. Or no, okay, when I press it again, it does a score display test. It goes through all the score displays and illuminates each number sequentially. Okay, now another press of it should bring me to the solenoid test. Goes through each solenoid and pulses it so you can know if any of them are bad. Now after that is a sound test. Here's the volume control here. Now here's the stuck switch test. And this number one switch, I've got identified here the switches. And switch number one is the left and right RO buttons. And what it looks like, I looked right in here, and it looks like this contact right here is stuck. I'm going to get an insulated device and pull it apart here. But now once I think it remembers the value, I'm going to use the needle nose. I'm going to turn it off and fix this contact, and it should register that it's been fixed. I can see that it's jammed in the closed position here. I'm now going to adjust the switch, and what you can do is just get this little center bar here and bend it to change the switch contact point gap. And I want it to be open in this position, but we need to make sure that there's enough follow through. See, right now the point gap is open, but need to make sure there's follow through and not just like a kiss of the contacts when the switch is pushed down, or you get arcing and bad switch action. So I'm going to push down this little lever that's activated by the pinball, and we'll see that's not quite enough. There's not quite enough follow through there, so I'm going to bend this little thingy in the middle up just a little bit more. It's got to be open. It's got to be open here, but when the pinball presses it, it's got to make the contact and follow through. And just bend it a little bit, and you bend the center thing. You bend the center spring. You don't have to bend the contact itself. Okay, right now contact points are open, and when the switch contact presses them down, they push down with follow through. So now I'm going to turn the pinball game on. I'm going to go through the self-test routine again, and it should not detect any stuck switches this time. Okay, here's test number 1, lamp test, score test, solenoid test, sound test, and it looks like it may still be indicating something. We'll see if there's any other problems over here. This one looks okay. Let's check this one here. Now that one looks good. Not sure why it's still indicating a stuck switches, because I think that everything has been fixed. The only way to really tell is to just play the pinball game. The last thing we do with a pinball game or jukebox or any kind of device with grounding is we always check that all the metal parts on the unit are grounded. Put one terminal of the ohm meter to the plug ground terminal and put it on the continuity checker, and then test things like the coin door. Make sure it's grounded. Test the pinball shooter. Even this up here is grounded, because the problem could be if one thing is grounded and another is connected to any kind of electrical component, there could be leakage and a voltage difference between the two things, and you could get a shock. So everything has to be bonded together inside the machine, and everything has to be connected to ground. Any metal parts that you could touch. I had a problem with a Chicago coin shootout arcade game where the gun was not grounded, and I got a shock on it when touching the gun, just because there was a voltage difference somehow between the gun and the metal coin door. So I had to make sure everything was grounded together, all the metal parts connected together, and with a grounded power cord connected to ground.